All right. Okay, guys. So today we are going to look at section 4.4. And what I've done is I already gave you guys some of the notes. I just went ahead and printed those out so that you didn't have to scramble to write them all down. Does it think that might be helpful? Because writing these proofs out sometimes is a lot of work, right? So I got kind of a little poem type thing here, right? This is section 4.4. See if I can get my marker going here. This is section 4. Whoa, it's writing. It's not writing. Let's try that again. Maybe a different color. Oh, there it goes. 4.4. We're doing section 4.4. It says, I woke up this morning not feeling like I should. The doctor told me it's not good. Something has happened to me. I came down with CPCTC. Doc said, when your triangles become identical, your corresponding parts must be equal. I said, when corresponding parts are the same, congruent figures were to blame. The bad news is CPTC is very contagious. The good news is you can use it to be courageous. Solving proofs can be tough. SSS, SAS, ASA, and AAS isn't always enough. CPCTC is the next device. You'll hear Kara Dismos, MD, give that advice. The test for CPCTC is to examine the geometry. Corresponding triangles is the start. CPCTC is the very next part. To find the cure for CPCTC blues, wait for non-congruent triangles to hit the news. Doctors have no pills for my CPCTC ills. Yes. What do you think, Ishmael? You like that? Yeah, me too. I like that too. I found that. I didn't come up with that, but I thought that was pretty cool. A little math poem to start the day. So today we're going to focus on this, whatever the CPCTC is. So in geometry, CPCTC is an abbreviation for the theorem involving congruent triangles. And here's what CPCTC stands for, right? I'm going to make sure I'm still on my marker here. Sometimes I forget I'm on my marker and it screws up. So corresponding parts of congruent triangles are congruent. That's what CPCTC stands for. Every time I see CPCTC, and by the end of the period, you'll be sick of hearing me say, you may already be sick of hearing me say it. It means corresponding parts of congruent triangles are congruent. In other words, you see these two triangles here? They are congruent. And if they are congruent, that means that every corresponding part is congruent to every corresponding part. In other words, angle A, which corresponds to angle D, are congruent. And so we have that written right here. Segment BC has to be congruent to segment EF, right there. By the way, there are 6 corresponding parts in congruent triangles. This almost kind of seems like we went back to section 4.1 if you remember section 4.1. But what we're doing here is now we're going to use this. You see this proof we just did here on the warm-up? We proved that triangles are congruent. What I could have asked you then is to remember that angle you said was congruent, angle N and angle, what was the other angle?
T.
Angle T. I could then on the very next step say angle N and angle T are congruent because of CPCTC. And that's what we're going to do on all the proofs today. And I've got 4 examples. We're going to work them out. Okay, this could be generalized to any shape. In other words, we could go past 3-sided figures and go to 4-sided figures or 5-sided figures, and it applies as well. Corresponding parts of congruent figures are congruent. Now notice in this situation, we don't call it CPCT, it's CF, I guess. I don't know. Okay, but we're going to only focus on triangles in this class for right now, okay? All right, so let's see what we got here. Now, guys, I'm going to call on some of you, so don't get too skittish here. Actually, maybe I should do this first. Let me do the first one. I'll do the first one. I'll let you off the hook. Now, just fill in the notes there as we kind of go along. We want to prove, now this one's a little bit different than what we just did on the warm-up. Here, we're trying to prove that this side is congruent to this side. That's what we want to prove. Here's what we know. We know that segment AB, in fact, let me go ahead and mark these. I'll mark them in, let's say, green. We know that segment AB is congruent to segment DE, so that's that. And by the way, that's given, right? We know that angle B is congruent to angle E, so angle B is congruent to angle E. By the way, that's also given. By the way, I'm doing the easiest one. That's kind of lame, isn't it? Anybody want to take a stab on what statement 3 is? I said I was going to do this one, but based on steps 1 and 2, you can probably guess what step 3 is. Yep. Segment BC, so I'll write that there. Segment BC is congruent to segment EF. That's given, and that's, now watch what I do here. I put 2 marks, and I put 2 marks. Again, you're putting 2 marks there because you don't want to say segment AB and BC are congruent. So we want to make those look different. We want to differentiate them. Now, looky there, guys. What do you see? I bet you Tomas knows the answer. Why do these 2 triangles have to be congruent? Remember, there's only 4 options. SSS, SAS, ASA, and AAS. It is the same thing as the one we just did. So this is going to be SAS. Ooh, and I forgot to include one little part here I wanted to. This here would have also been an S, right? Now, guys, you don't have to do this, but I like to write these little letters right here just to help me figure out, oh yeah, that's SAS. You see that little trick? Just kind of helps you not screw up. Like if you got SAS, you're not going to use ASA, right? Because you have 2 S's and 1 A. Now, can you guess what step 5 is? What's the last step of the proof always? Yeah, whatever it is you're trying to prove, right? So this is going to be segment CA is congruent to segment FD. That's what we're trying to prove. And the reason's going to be, and this is the most important step of the whole proof, CPCTC. In other words, corresponding parts of congruent triangles are congruent. We just established that the 2 triangles are congruent. So all of their corresponding parts have to be congruent. This is CPCTC. In other words, I'm basically telling you the good news about this week's homework, if you felt like last week's was really hard because learning all this stuff, we're doing the same thing. We're doing the exact same homework as we did last week. We've just got one additional step. And guess what it is? CPCTC. Oh, and I'm going to come back to this for just a second. I'm going to go back to this. You remember this little poem we did at the very beginning? Remember in the poem here it says CPCTC is the very next part. So once you get the triangles congruent, it's the next part. So don't use CPCTC until you have congruent triangles. If you don't know the triangles are congruent, you can't use CPCTC. You got to show they're congruent first. So let's go and look at another. Actually, let me hold on here. Are you guys okay on this one now? Did you get all the steps? Did you write CPCTC on step 5? Okay, write that down. Okay. Do you think these notes might help you guys with this? Yeah. All right, so let's do another example. What do you guys think the reason is for number 1? Why is E the midpoint of BD and BD bisects segment AC? Because it's given. That's an easy one, right? So that's given. So I'm going to write 1 given. Now I'm going to draw what I can here. Actually, there's not much I can draw here. So now let's go and analyze this. I'm going to put step 2. Step 2. It says that E, this point right here, is the midpoint of BD. It's the midpoint of BD. BE is congruent to what? ED. Why? We just did it over there on the warm-up. Definition of midpoint. They told us it was a midpoint. Okay, so that means that this segment is congruent to this segment. So we got a side congruent to a side. Awesome. Now look at the second part of the given. It says segment BD bisects AC. It bisects AC. So guess what that means about AE and EC? Yep. Why is that true?
Oh,
because it's a bisector. I'm going to put definition of segment bisector. Guys, if it's a bisects a segment, it passes through the midpoint, but if it passes through the midpoint, we know that those two things are going to be congruent. So when I say something bisects an angle or something bisects a segment, I'm saying that those two things are going to be congruent. So this is congruent to this. Okay, good. Oh, by the way, we got another side congruent to another side. Woo! Vaughn, I'm not going to let you make my day again. Okay, but you already know what the next one is. Does anybody know what the next step is? What is the next step on this proof? What has to be congruent in those two triangles? And do me a favor, don't look up here at this example we did on the warm-up, okay? That's a joke.
I'll try to guess.
Ishmael?
I'm just guessing here, so B-A-E.
Not B-A-E, B-E-A, angle B-E-A. That's this angle right here.
And then C-E-D.
C-E-D are congruent. Why are they congruent? Vertical angles are congruent. Boom. Nice job, Ishmael. That's exactly right. Now you might say, well, Mr. Allen, this seems an awful lot like the one we did on the warm-up. Yes, it is. A lot of these proofs are very similar. So you should get to the point where you know, oh, vertical angles. Check for those vertical angles. Oh, by the way, that's an angle congruent to an angle. I bet you Tomas knows what the answer is for the next one.
It's the same thing.
It's the same thing again. What is it, Tomas? It is SAS. So for step 5, now here's where we got to be careful, right? We got to do them in the correct order. Triangle BEA is congruent to triangle BEA has to be congruent to triangle what? CED. Now, guys, I'm going to warn you. You got to be very careful about the order in which you do things. And let me show you. I'm going to do it in green. You see how this angle B up here is next to the single-sided congruent side? That's why it had to be D. Oh, I did it wrong, didn't I? You were right. I think I said it wrong. Let me fix my mistake, guys. I am so sorry. I was telling you were wrong, and I think you were right. I'm going to fix it. B has to go with D. So if you said D, I am super sorry. I screwed up. What's the next letter? E and C. Did I tell you were wrong when you were right? I am so sorry. You were right. I feel really bad. I wasn't trying to be a jerk there, and I came off as a jerk, and I'm sorry. Be very careful about that. Some students will see BEA, and they'll want to just do CED. But that doesn't make sense because B is right next to this one-sided congruent symbol, so it has to be this D down here. E and E are both the same, so that's good, and then C is going to be the last one. What does the last step have to be?
The proof.
Yep, so what's step 6? Step 6? angle B is congruent to angle D. And why is that true?
PA, whatever the thing is.
C, P, C, T, C.
So hard to say, bro.
It is hard to say, but guys, you're going to learn it and you'll know it. C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Now, that problem was very similar to what we did on the warm-up, but it was a little bit more involved. But that was a good one for us to do next, right?
Mhm.
Any questions on this one? Okay. Now I've got two more, but I think I'm going to stop after this one here, okay? This one here, we've got given that CD is an angle bisector of angle ACB, and we know that segment CA is congruent to segment CB. So that's given. We've got that. In fact, let me mark that. We know that CA is congruent to segment CB. And then it says in step 2, angle ACD is congruent to angle BCD. So that's this angle here and that angle there. Does anybody know why those two angles have to be congruent based on what we said in number 1? It is. That's exactly right. Definition of angle bisector. So up here it said that this segment right here was the angle bisector. So it cuts it into two congruent angles. Just like in the previous problem, we had a segment bisector that divides it into two congruent segments. Oh, I'm not doing a good job of modeling this. This was a side congruent to a side, right?
Mhm.
What's this one?
It's
An angle congruent to an angle, right? All right. Now, I am not helping anybody with step 3.
would it be reflexive? No?
Does anybody see anything else that has to be congruent in these two triangles? Ishmael?
I'm probably wrong, but I said CD is congruent, so.
Absolutely, and you are not wrong. You are completely correct. So segment CD is congruent to segment CD. So I will mark that. And why are they congruent?
Reflexive.
Reflexive. You know what, buddy? I think that deserves a Smartie. Tomas! Do you notice anything here, buddy?
Yeah.
What do you notice, Tomas? What do you notice? What do we got again?
The same thing.
This SAS again, isn't it? John, can you tell me what the last statement has to be? What does the last step always have to be, Sean?
I don't know.
It's usually whatever we're trying to prove, right? What are we trying to prove here? Segment AD is congruent to segment BD. Do you know why? You got it, buddy. CPCT. Have you gotten a Smartie yet today?
No.
You just got one. I'm going to stop this right here.